Hello friends, welcome back to India for IAS. This is Manjunath Mudod. In this video, we are going to study about International Year of Quantum Science and Technology. So, largely in this video, we are going to study about what is quantum science and technology, what are its applications, what are its features, and some key concepts associated with quantum science and technology. So, this topic falls under GS3 paper. So, this quantum science, it falls under GS3 paper, science and technology part. Science and technology part. Within science and technology, it falls under recent developments in science and technology. This topic is very important for both prelims and mains. Recently, the United Nations it declared that the year 2025 will be International Year of Quantum Science and Technology. So, the aim to declare 2025 as the International Year of Quantum Science is to increase the public awareness about the quantum science and its applications through a year-long series of worldwide activities. So now we will briefly study about the background of the proclamation of the 2025 as the International Year of Quantum Science and Technology. Initially, the resolution was led by Mexico in May 2023. So Mexico, it led a resolution to proclaim 2025 as the International Year of Quantum Science and Technology. Then after that, nearly 60 countries supported the Mexico's initiation. Then it was adopted by the UNESCO General Conference in November 2023. So in May 2024, Ghana and it's supported by another 70 countries submitted a draft resolution to the United Nations General Assembly, which accepted on June 7, 2024 to declare the year 2025 as the International Year of Quantum Science and Technology. So now the question arises why the year 2025 has been chosen to celebrate as the International Year of Quantum Science and Technology. For this, the reason is the year 2025. It marks the 100th year of the 100th anniversary of the Werner Heisenberg's foundational work in quantum mechanics. So in the year 1925, Werner Heisenberg, he published a paper on quantum mechanics for which he was awarded Nobel Prize. And the endorsement of 2025 as the International Year of Quantum Science and Technology has received many endorsements from many international institutes like International Union of Pure and Applied Physics, Chemistry, Crystallography. Now we will try to understand the what is quantum science and technology exactly and the few key concepts associated with quantum science and technology. So quantum mechanics means a fundamental theory in physics. So it describes the physical properties of the nature at the scale of atoms and subatomic particles. Before the invention of the quantum mechanics or discovery of the quantum mechanics, whatever the laws of physics that we have were at the macro scale, not at the micro scale, that is not at the scale of atoms and subatomic particles. We have laws related to gravity, we have laws related to motion. These are all related to the macro scale, not at the micro scale. Whereas the quantum mechanics, it deals with the nature of particles at the scale of atoms and subatomic particles, that is at micro and nanoscale level. Coming to the historical development, it was originated in the early 20th century. That was in the years of 1920s, we can say. Then the famous contributors are Max Planck, Albert Einstein, Niels Bohr, and Werner Heisenberg. These were the few great scientists. They worked towards the development of the quantum science and technology. So coming to the key concepts in quantum mechanics are quantum states, superposition, entanglement, uncertainty principle. So we will discuss one by one. The first one is quantum states. Quantum state means the state of the quantum system is described by a wave function which contains all the information about the system. It means the quantum state is expressed in the form of a mathematical equation. So that is what quantum state. The second key concept is superposition. Superposition says that it is a principle stating that a particle can exist in multiple states simultaneously until measured. It means superposition means a particle can exist in multiple states simultaneously. At the same time, it can be in multiple states. The meaning of superposition. The third key concept is entanglement. So it is a phenomena where particles become interconnected and the state of one instantly influences the state of another regardless of the distance. For example, if there are two particles, so these two particles are, they are say around 100 kilometer away. So the state of particle 1 affects the state of the particle 2. So they are interconnected. So this phenomenon of interconnection of the quantum particles is called as entanglement. Then the fourth concept is uncertainty principle. So this principle was formulated by Werner Heisenberg. And the principle states that we cannot know both the position and the speed of a particle, such as photon or electron, with perfect accuracy. It means it is not possible to know both position and the speed of a particle simultaneously. So that is the meaning of the uncertainty principle. Now we will try to understand the quantum technologies or the applications of the quantum science. So the first application is quantum computing. So quantum computing, it utilizes the qubits, which can represent both 0 and 1 simultaneously. In digital computer, we have bits called 0 and 1. So whereas in quantum computing, we have qubits, that is quantum bits. And these qubits, they represent both 0 and 1 simultaneously due to the principle called superposition. So earlier we have discussed what is superposition. So based on that concept of superposition, the qubits, it represents both 0 and 1 simultaneously. These quantum computers, they are capable of solving complex problems much faster than the classical computers. So whatever supercomputers we have at present, they are termed as classical computers. Whereas the upcoming, in the future, we are going to witness quantum computers. These quantum computers, they can solve complex problems much faster than the present generation supercomputers. So coming to the application of quantum computing, so this finds application in cryptography, optimization problems, drug discovery, and artificial intelligence. So these are the few applications of quantum computing. So the next technology is quantum communication. So this quantum communication, it uses the quantum entanglement for secure communication. So while studying the key concepts, we have gone through quantum entanglement. So what is quantum entanglement? It is a phenomena where particles become interconnected and the state of one instantly influences the state of another. So if there are two particles, if they are separation of say around 100 kilometer, the state of one, both are interconnected, but the state of one particle influences the state of another particle. So based on this entanglement phenomena or entanglement principle, this quantum computing, it works. So it enables the secure communication. So if there is a quantum communication, then the enemy countries, they cannot intercept the communication. So that is the meaning of secure communication. So this quantum communication, it also uses one more concept called quantum key distribution. So this quantum key distribution, it enables the secure transmission of encryption keys, which are theoretically impossible to hack. The third technology is quantum sensing and metrology. So this quantum sensing and metrology, it uses the quantum systems to make high precision measurements. The applications include highly sensitive accelerometers, gyroscopes, and magnetometers. Then the fourth technology is quantum materials and devices. So materials with properties that are significantly influenced by quantum mechanics, they are used in quantum materials and devices. Examples include superconductors, quantum dots, topological insulators. The next technology, the fifth technology is quantum cryptography. So this quantum cryptography, it ensures secure data transmission using principles of quantum mechanics. So the quantum resistant algorithms, development of cryptographic algorithms that can withstand attacks from quantum computers. So then we have a quantum simulation. So the quantum simulation, it states that it simulates the complex molecular structures for drug discovery and new material development. So the optimization problems include, it solves complex optimization problems in various fields, including logistics and finance. The seventh technology is quantum imaging. So this quantum imaging, it is helpful in enhanced imaging techniques. This improves the imaging resolution and sensitivity. So this is useful in medical diagnostics and astronomical observations. So whatever present imaging technologies we have, so its resolution is limited. So in order to enhance that resolution and to detail image of the sensitive parts of the human body and astronomical observations, so this quantum imaging is very helpful. So this quantum imaging, it is a non-invasive diagnostic. Then next we have quantum radar. So this quantum radar, it can be used for stealth detection. So the quantum radars can detect the stealth aircrafts and the objects that are otherwise difficult to track. So in the common radar, so if the country, if any country, country A, if it is using radars, it can easily intercept the enemy country aircrafts, and drones. If these aircrafts, if they are stealth, if they are using stealth technology, then it is difficult to find or difficult to identify the enemy country aircraft and drones which have stealth technology. So the common radar cannot be used. In that case, if the country A, if it is going to use quantum radars, then even the quantum radars can easily detect the stealth technology aircrafts and drones. So that is the application of the quantum radar. In addition to this, this quantum radar can also be used in the weather monitoring and environmental observations. So the next technology is quantum teleportation. So this quantum teleportation, it can be used in data transfer. So there are experimental transfer of quantum states over long distances. So this can potentially revolutionize the data transfer mechanism. At present, in order to transfer data, we are using various mechanisms. So this mechanism can be enhanced using quantum teleportation. So long distance data transfer can happen within microseconds or milliseconds with the use of quantum teleportation. The one more concept associated with quantum teleportation is quantum internet. So this quantum internet, it is the basis for developing the future quantum internet with highly secure communication channels. Then the last technology is quantum batteries. So this quantum battery, they can be used in energy storage. At present, we have lithium ion battery, hydrogen fuel cells, methane fuel cells. So various battery energy storage devices are there. So the quantum batteries, they have potential for more efficient energy storage and faster charging compared to the classical batteries that are existing today. So these quantum energy batteries, they can be used in the storage of energy generated by the renewable energy technologies. So this is all about the quantum technologies or applications of the quantum science and technology. So coming to the challenges associated with quantum science and technology. So there are technical challenges in building stable and scalable quantum computers. Then the high cost and complexity of the research and development makes it unavailable for the many developing and least developed countries. Then the next challenge is need for skilled workforce and interdisciplinary collaboration is one of the major requirement to build the quantum technologies. So these are the three challenges associated with quantum science and technology. Now we will look into the India's initiatives on quantum science and technology. So the first one is National Quantum Mission. So it was approved in the April 2023. So it was approved in the year 2023 in the month of April. So its mission aim is to create a vibrant quantum technology ecosystem through scientific and industrial research and development. So this mission will run from 2023 to 2030. So it will run from 2023 to 2030. So the estimated cost of this mission is around 6,000 crore rupees. Cost is around 6,000 crore rupees. The mission's goal also includes the developing quantum software and building quantum computing hardware for practical applications. So the next initiative is Quantum Enabled Science and Technology, also called as Quest. So it was launched in the year 2018 by Department of Science and Technology. So it also aims to create an ecosystem for quantum science and technology. Then next we have National Mission for Quantum Technologies and Applications. So it was announced in the year 2020. So it aims to develop a quantum industry in India with an investment of around 8,000 crore rupees. So the next initiative is Quantum Communication Lab. So it was inaugurated in October 2021. So it was inaugurated in October 2021 by C. Dot. So this quantum communication lab, it unveiled the India's first quantum key distribution solution. So this is all about the quantum science and technology, the technologies associated with quantum science, and the India's initiative on quantum technology. So based on the topic that we have discussed so far, that is quantum science and technology. So here we have provided one prelims practice question. The question contains 4 statements. Go through the statement and comment your answer. The answer and detailed explanation for this question is available in the PDF handout. The handout also contains the detailed notes of this video. So you can join our Telegram channel and download this PDF. Thank you for watching. See you in the next video. Till then, happy learning.